now in this video we come back to our example and we want to calculate the 95% confidence interval for the example of the IQ score. What did we say? We said that our psychology students cleverer. The IQ score of psychology students were higher than the general population. Now we want to get both 95% and 90% confidence interval. So what did we do? We took a sample of size 25 students and then got the X bar, the average IQ score of these students, and noticed that the X bar was 107. Now, in order to get 95% confidence interval, remember that I said I have got 95% confidence interval, yeah? So, if I'm doing 95% confidence interval, my this lower one and upper one is 1.96 and minus 1.96, all right? So, what I do, confidence interval is always the estimate of the parameter, which would be the statistic. If we are doing now a confidence interval for the mean, we are talking about estimate of mu, which is X bar, plus minus a factor times a standard error, which is sigma of X bar. It is the standard deviation of the means that we talked about them a lot in the previous videos. So here we had a sample of size 25 and the mean of the IQ scores was 107. So I will have the estimate for mu was 107, which is the X bar. Now, plus minus the factor here, because I'm doing 95% confidence interval, is 1.96. So plus minus 1.96. Why do I do plus minus? It means that once I add, once I subtract. Or we can say that we want this value of the standard deviation below the mean and this value standard deviation above the mean. Times it by standard error. You remember standard error was sigma of X bar. It was 3. How did we get it? Population standard deviation was 15 divided by square root of 25. All right, how do we calculate that? A lot of students have got difficulties calculating this. First, you multiply these two together on your calculator. Once you got the number for this one, once you add it to 107, write it down, then subtract it from 107, write it down. That would be your upper bound and lower bound. If you want to do, and that is the formula we have used, but don't get bogged down with the formula, just the way I told you. And if you want to do 90% confidence interval, see here, why do we have 1.96? Because this area under the curve is 2.5%. And how do you get that 2.5%? You go to your tables or ESCI and look at the probability, which is 2.5% in the body probability percent to the tail, yeah, in the book. And then in ESCI, you will do it just using the ESCI in lab 5. You will learn it. And then if I'm doing 90% confidence interval, it means that 90% confidence interval, the area here is 90%, so here is 5%, and here is 5%. And therefore, here would be, these two would be 1.64 and minus 1.64. All right? And